Natural explosion took place at Yellowstone National Park. A geyser suddenly.
Two explosions, one day. One location that has the entire global volcanological community refusing to sleep. Yellowstone, the supervolcano sitting beneath 45,000 square miles of American wilderness, just did something that monitoring stations have never recorded in the modern era. And the numbers coming out of Wyoming right now are not just breaking records. They are breaking the models that scientists built those records on. The ground is moving, the heat is rising, and the question that nobody in the United States government wants to answer out loud is now impossible to avoid. Hi, my name is Daniel, and this is Natural Disasters. What actually happened? The timeline: May 2026, Yellowstone National Park. Population of permanent residents inside the caldera boundary, approximately 300. Population of the planet, standing directly above one of the three largest supervolcanoes ever to exist on Earth. May 7th, 2026. 6:22 in the morning, Mountain Standard Time. The first explosion detonates without warning in the Biscuit Basin hydrothermal area, located in the Upper Geyser Basin, approximately 2 miles northwest of Old Faithful. The scientific term for what happens when superheated water trapped beneath the surface flashes instantly to steam and blows the rock above it apart. Rips a crater measuring 60 feet across into the boardwalk area. Witnesses describe the sound as a cannon shot echoing off the surrounding tree line. Debris, including rocks, mud, and scalding water, launches 150 feet into the air. Park rangers begin evacuation of the Upper Geyser Basin immediately. Visitors who arrive for the morning Old Faithful eruption are directed north along Highway 89. Cell service, as anyone who has ever visited Yellowstone knows, is essentially decorative out there. Communication delays mean that for 40 minutes, incident commanders at Mammoth Hot Springs are working from incomplete information. Then the second explosion hits, 11:47 in the morning, same day. Different location, a second hydrothermal detonation tears open a new crater at Norris Geyser Basin. This explosion is larger. The crater measures over 90 feet in diameter. Ground sensors at the Norris monitoring station register a seismic signature equivalent to a magnitude 2.8 earthquake in the same instant the explosion occurs. Two hydrothermal explosions, one day, 22 miles apart. By 2 in the afternoon, Yellowstone National Park issues a full closure of all hydrothermal basin areas. By 4, the closure expands to include all backcountry trails within 5 miles of the caldera boundary. By 6, the Utah seismograph stations confirm that seismic activity in the park has elevated to levels not recorded since the swarm events of 2009. The U.S. GS Yellowstone Volcano Observatory updates the volcano's alert level. The word they use is advisory, but the number of scientists making emergency calls to each other that evening suggests the internal conversations are using somewhat stronger language. Yellowstone's anatomy of destruction. Here is the thing about Yellowstone that most people fundamentally misunderstand. And I say this with genuine affection, because I misunderstood it myself for years. Yellowstone is not a volcano in the way that Mount St. Helens is a volcano. It is not a cone. It is not a mountain that might blow its top. The volcano is the landscape. The entire Yellowstone caldera, 45 miles long, 30 miles wide, is the collapsed remnant of the last super eruption. You are not looking at a volcano when you visit Yellowstone. You are standing inside one. The magma chamber sitting beneath the park is not a simple pool of molten rock. It is a layered, complex, partially molten system extending from 3 miles beneath the surface down to depths exceeding 30 miles. Recent seismic tomography, the technique that uses earthquake waves to take 3-dimensional images of the Earth's interior, reveals that the upper magma reservoir alone measures roughly 55 miles long, 18 miles wide. That is enough molten material to fill the Grand Canyon approximately 11 times. Below that sits a second, deeper reservoir, larger, hotter. The hydrothermal system layered above this magma is equally staggering. Yellowstone contains more than 10,000 hydrothermal features, representing the largest concentration of hydrothermal activity on the surface of the planet. This system is not decorative. It is the pressure release valve sitting between 2 million years of accumulated magmatic energy and the surface of the Earth. When that pressure release valve starts behaving erratically, when explosions start tearing craters in the boardwalk 2 miles from Old Faithful, the question is not whether something is happening. The question is what exactly it means. And that is where the data becomes genuinely alarming. The numbers that are breaking scientists. Let me give you the numbers, because the numbers are where this story stops being dramatic narration and starts being something that should make every single person watching this video ground deformation. The Yellowstone caldera inflates and deflates in cycles that scientists call breathing. This is normal. What is not normal is the rate. GPS monitoring stations operated jointly by the U.S. and the University of Utah have recorded caldera uplift of approximately 4.7 centimeters since January of 2026. The historical average annual uplift during active inflation periods runs around 2 centimeters per year. The current rate is running roughly 5 times above that baseline. Seismic activity. In the 30 days preceding the May 7th explosions, the Yellowstone Seismograph Network recorded 943 individual seismic events within or immediately adjacent to the caldera boundary. The average monthly seismic count for non-swarm periods runs between 100 and 200 events. 943 events in 30 days represents the highest pre-explosion seismic count recorded at Yellowstone in the instrumental record. Helium-4 emissions. This one gets less attention than it deserves, probably because it sounds less cinematic than earthquakes and explosions. So, let me explain why it matters enormously. Helium-4 is a gas that forms through the natural radioactive decay of uranium and thorium deep in the Earth's crust and mantle. When it starts appearing at the surface in elevated quantities, it means deep crustal fluids are moving upward. It means the plumbing system connecting the deep magma reservoir to the surface is becoming more active. Sensors at Yellowstone are currently recording helium-4 flux rates approximately 40% above the baseline established over the previous decade. Carbon dioxide emissions. The Norris Geyser Basin area, the site of the second explosion on May 7th, has recorded CO2 flux measurements in the weeks preceding the event that run nearly double the previous maximum readings for that monitoring station. Dr. Jake Rosen at the U.S. GS Yellowstone Volcano Observatory describes this particular reading in a published statement as anomalous and warranting continued close observation. That is scientist language for, we are not sleeping much. Water temperature anomalies. Thermal monitoring of Yellowstone Lake, which sits directly above a section of the caldera, shows average water temperatures in the northwestern basin running 2.3 degrees Celsius. Spread across a lake that is 14 miles long and 7.5 miles wide, sitting directly on top of a hydrothermal system, 2.3 degrees represents an enormous amount of additional thermal energy moving upward through the system. Every single one of these numbers is elevated. Every single one of them has been trending upward, and every single one of them hit its highest recorded value within the 60-day window leading up to the 2 explosions on May 7th. The history that haunts every geologist. To understand why those numbers matter, you have to understand what Yellowstone has already done. Not in theory, not in worst-case modeling, what it actually did repeatedly to this planet. 2.1 million years ago, Yellowstone's first supereruption deposits volcanic material across an area covering roughly half of what is now the continental United States. The volume of material ejected in that single event is estimated at 6,000 cubic kilometers. For context, the 1980 eruption of Mount St. Helens, which killed 57 people and generated the largest recorded landslide in human history, ejected approximately 1 cubic kilometer of material. Yellowstone's first supereruption was 6,000 times larger, 1.3 million years ago. The second supereruption, smaller than the first, but still depositing volcanic ash across thousands of miles of North America. The event triggers a volcanic winter that scientists estimate drops average global temperatures by several degrees for years afterward. Growing seasons collapse, species disappear 630,000 years ago. The third supereruption, the one that creates the caldera visible today. 1,000 cubic kilometers of material ejected. The explosion column reaches the stratosphere and circles the globe. To be absolutely clear, and I want to be fair here because I believe in being accurate, the USGS states plainly that Yellowstone is not overdue for a super eruption because volcanic systems do not operate on fixed schedules. The average interval is not a due date. That is a legitimate scientific point, and it is important. But here is the other thing the USGS will tell you, equally plainly, if you read their technical publications rather than just their public communications. The Yellowstone system does not need a super eruption to cause catastrophic damage. Smaller eruption scenarios, lava flows, localized explosive eruptions, sustained hydrothermal activity, carry their own devastating consequences for the region. And the region, in this case, includes cities. The 1988 warning. Nobody remembers. 1988. I know what you are thinking. 1988 was the year of that massive Yellowstone wildfire that burned nearly 800,000 acres of the park. And yes, that happened. That was genuinely catastrophic and it deserves its own video. But something else happened at Yellowstone in 1988 that received almost no public attention, and that scientists studying the current situation keep and in the careful language of their published observations. A hydrothermal explosion at Porkchop Geyser in the Norris Geyser Basin, the exact same basin where the second explosion detonated on May 7, 2026, blew a 5-foot crater into the surrounding rock and ejected debris across an area of roughly 25 feet. Nobody was killed. The event was documented, cataloged, and largely forgotten outside the volcanological community. In 2003, a large hydrothermal explosion at Norris triggered what scientists call a thermal disturbance, a measurable increase in ground temperatures, new vent openings, and the temporary drying of previously active features across the basin. The park partially closed. Scientists got excited. Then activity subsided, the park reopened, and the news cycle moved on. In 2009, a swarm of over 1,000 earthquakes shook the Yellowstone caldera over the course of several days. The USGS issued statements. Scientists monitored closely. Activity declined. The news cycle moved on. Here is what connects all of these events to May 7th, 2026. Every single one of them occurred at Norris Geyser Basin. Every single one of them was preceded by elevated ground deformation rates, anomalous gas emissions, and seismic activity above historical baselines. Every single one of them was followed by a period of elevated hydrothermal surface activity, and every single one of them was smaller than what just happened. The pattern is not hidden. It is sitting in the published scientific literature in plain sight. The question that researchers are currently wrestling with is whether the events of May 7th represent the continuation of a pattern of episodic, manageable hydrothermal unrest, or whether they represent the opening act of something the pattern has never produced before. Human stakes, 3 million visitors, and a city downwind. Let me tell you about the human geography of Yellowstone, because this is where the story gets very real very quickly. Approximately 4 million people visit Yellowstone National Park each year. In May, visitor counts run roughly 300,000 per month, concentrated heavily in the accessible hydrothermal basin areas. The Upper Geyser Basin, where the first explosion detonated at 6:22 on May 7th, sees more daily foot traffic than virtually any other location in the park. The boardwalk system around Old Faithful alone handles upward of 10,000 visitors on a peak summer day. The park has exactly 3 road entrances capable of handling significant evacuation traffic. In normal conditions, summer holiday gridlock on these roads can hold vehicles stationary for hours. In an emergency evacuation scenario, and here's the part that emergency planners at the Wyoming Office of Homeland Security describe with visible discomfort in their contingency documents, the road network inside Yellowstone is not designed for mass evacuation. It was designed for scenic driving, but the visitor count, staggering as it is not actually the largest human stakes number in this story. Salt Lake City, Utah, sits approximately 310 miles south of the Yellowstone caldera. Population, over 200,000 in the city proper, over 1.2 million in the metropolitan area. Prevailing wind patterns across the region run predominantly south to southwest. In an explosive eruption scenario producing a sustained ash column, and I want to be clear that this applies even to a moderate eruption, not a super eruption, Salt Lake City sits directly in the primary fallout corridor. Boise, Idaho, population over 230,000. 260 miles west, northwest. Also in the wind pattern, Denver, Colorado, population over 700,000 in the city, nearly 3 million in the metro. Ash deposition modeling for even a relatively small Yellowstone explosive eruption shows Denver receiving centimeters of volcanic ash fallout. Volcanic ash is not like snow. It does not melt. It weighs approximately 1.5 tons per cubic meter when wet. It is abrasive enough to destroy jet engines. It contaminates water supplies, collapses roofs, and renders agricultural land unproductive for years. A single centimeter of ash accumulation across the Denver metropolitan area would cost billions of dollars in infrastructure damage alone before a single human health impact is counted. The USGS Volcano Hazards Program publishes detailed ash fallout modeling for Yellowstone eruption scenarios. I would encourage every single person watching this video to look those maps up. They cover a substantial portion of the continental United States, and they are based on eruption scenarios considerably smaller than a super eruption. 300 visitors were inside the active hydrothermal zones when the May 7th explosions occurred. By extraordinary luck, and I mean this genuinely, the park had a slow morning due to overcast weather, keeping casual visitors at their hotels. Nobody was killed. Nobody was standing on the Biscuit Basin boardwalk when it ceased to exist. That was luck. Luck is not a contingency plan. What scientists are saying, and not saying, the USGS Yellowstone Volcano Observatory issued a formal statement on May 7th at 3:45 in the afternoon, Mountain Standard Time. I have read it several times. It is a document of considerable scientific care, and I want to give it genuine credit for the information it contains. The statement confirms both explosions. It provides accurate size estimates for the craters. It notes the elevated seismic activity in the preceding weeks. It describes the helium and CO2 readings as anomalous. It raises the volcano alert level to advisory. And then it says, and again I am paraphrasing here, but accurately, that there is no indication of magmatic involvement in the explosions, that hydrothermal events of this nature are a known feature of Yellowstone's geological character, and that visitors should follow park closure guidance. What it means? The specific signature of the May 7th explosions is consistent with hydrothermal activity, driven primarily by superheated water and steam, rather than directly by fresh magma reaching the surface. That is accurate. Hydrothermal explosions at Yellowstone can and do occur without direct magmatic involvement. What it does not mean, that the magmatic system beneath Yellowstone is not the ultimate source of the energy driving that hydrothermal activity. Because it absolutely is. Every joule of heat in Yellowstone's hydrothermal system comes from the magma chamber below. When the hydrothermal system becomes more energetic, when explosions start tearing craters in the ground, it is because more heat is moving upward from below. You cannot separate the symptom from the source. Dr. Marcus Teller at the Scripps Institution of Oceanography, who is not affiliated with the USGS and is therefore slightly less constrained in his public language, gave an interview to Science magazine on May 9th that I think deserves significant attention. He described the gap between the USGS public statement and the underlying data as, quote, the difference between telling people it is raining and telling them there is a hurricane offshore. Dr. Teller was not saying an eruption is imminent. He was saying that the public communication framework around Yellowstone is calibrated to prevent panic rather than to accurately convey uncertainty. And that calibration, he argues, leaves the public functionally unaware of what the data actually shows. I am not here to create panic. Panic is not useful, and it is not honest. But I will tell you what the data shows and let you decide how you feel about it. The domino chain. Could this trigger something bigger? Here is the question I have been building toward. And here is where I need you to stay with me, through some geology that is genuinely complex, but genuinely important. Yellowstone does not exist in geological isolation. It sits at the northeastern end of the Snake River Plain, a volcanic track running across southern Idaho that represents the surface scar left by the North American tectonic plate, moving over the Yellowstone hotspot over the past 17 million years. The hotspot itself is stationary. The continent moves over it, and everywhere the continent has passed over that hotspot, it has left volcanic calderas, lava fields, and deeply fractured crust in its wake. The Wasatch Fault Zone runs along the western edge of the Wasatch Mountains through central Utah, directly beneath Salt Lake City. It is one of the most seismically hazardous fault systems in the United States. Geological studies have established that large earthquakes on the Wasatch Fault historically correlate in timing with periods of elevated activity at Yellowstone. The mechanism is debated. Stress transfer through the crust is complex, but the correlation in the geological record is not. The Teton Fault, running along the base of the Teton Range approximately 20 miles south of the Yellowstone caldera boundary, is capable of producing earthquakes up to magnitude 7.5. It last produced a major rupture approximately 8,000 years ago. Current GPS measurements show the Teton block is moving at rates that suggest accumulated stress approaching or exceeding what the fault experienced before that last major rupture. And then there is the Cascade Range, Mount Rainier, Mount Hood, Mount Shasta, Mount Baker, the volcanic arc running along the Pacific coast from Northern California through Washington state. These volcanoes draw their magma from a fundamentally different tectonic process than Yellowstone, subduction rather than a hotspot, but they share deep crustal connections through the North American plate. Historical eruption chronologies show periods of elevated activity across multiple Cascade volcanoes, correlating with Yellowstone's own periods of heightened unrest. I want to be careful here, because the science on these regional connections is genuinely uncertain, and I am not going to overstate it. But I will say this. The idea that Yellowstone is a completely isolated system whose behavior has no implications for surrounding geology is not supported by the geological record. When Yellowstone gets energetic, the region around it tends to get energetic too. And right now, Yellowstone is getting energetic. The climate wild card. We have to talk about this because it is the variable that almost nobody is factoring into the Yellowstone conversation, and it changes the risk calculus in ways that matter enormously. The climate system in 2026 is not the climate system in which all of our Yellowstone historical data was collected. Average global temperatures are running approximately 1.4 degrees Celsius above pre-industrial baseline. The hydrological cycle has accelerated. Precipitation extremes are increasing. And here is the specific connection to Yellowstone that keeps climate scientists and volcanologists having very uncomfortable joint conversations. Yellowstone's hydrothermal system is fed partly by surface water, precipitation, and snowmelt that percolates down through fractured rock, gets superheated by the magma system below, and returns to the surface as geysers, hot springs, and steam vents. As precipitation patterns shift and as the snowpack across the greater Yellowstone ecosystem changes in volume and seasonal timing, the recharge dynamics of the hydrothermal system change with it. Current snowpack across the Yellowstone Plateau is running approximately 30% below the 30-year average for this time of year, consistent with a multi-year drought pattern across the western United States. Reduced surface water input to a hydrothermal system does not reduce the thermal energy driving that system. What it does is concentrate that energy. Less water absorbing the same amount of heat means higher temperatures, higher pressures, and a hydrothermal system running closer to its explosive threshold. Scientists studying the hydrothermal explosion record at Yellowstone, which extends back thousands of years through the geological record, have noted a correlation between periods of reduced precipitation and increased hydrothermal explosion frequency. The correlation is not perfect, but it exists, and it is operating right now. A Yellowstone supereruption interacting with an already climate-destabilized atmosphere would produce effects that our existing models frankly cannot fully predict. Volcanic winters from past super eruptions occurred against a climate baseline that no longer exists. The feedback interactions between volcanic aerosols and an atmosphere already loaded with greenhouse gases represent genuinely uncharted scientific territory. The climate crisis has not caused Yellowstone's current unrest, but it may be making a restless system more volatile. And if the worst ever happened, it would make the consequences orders of magnitude harder to survive. The philosophical close. There is a question underneath all of this data, underneath all of these numbers and fault lines and hydrothermal explosion craters that I keep coming back to. What does it mean that 4 million people visit Yellowstone every year? That families pose for photographs in front of geysers that are essentially pressure valves on a system capable of ending civilization as we know it? And almost none of them know the actual geology of what they are standing on? I do not think the answer is that we should stop visiting Yellowstone. It is one of the most extraordinary places on Earth. The fact that it is extraordinary is precisely because of the geological forces that make it dangerous. You cannot have one without the other, but there is something deeply uncomfortable about the gap between the official communication, advisory level, no indication of magmatic involvement, follow park closure guidance, and the reality that the data describes. We have built a public communication framework around Yellowstone that is optimized to prevent panic in the short term. What it may be doing in the long term is leaving millions of people functionally unable to make informed decisions about a risk that is not theoretical. It is not distant. It is not a worst-case projection for 2040 or 2080. It is a supervolcano that just produced 2 explosions in a single day in May 2026. With every measurable indicator running at or above historical maximums. The 2009 earthquake swarm subsided. The 2003 thermal disturbance quieted. Activity has always returned to baseline before, but Yellowstone is not a system that cycles back to zero. Every uplift episode leaves the caldera floor slightly higher than before. Every hydrothermal explosion leaves a crater that did not exist previously. Every elevated seismic period adds stress to faults that are already loaded. The system does not reset. It accumulates. 2 million years of accumulation. And May 7th, 2026 just added to the total. The ground beneath Yellowstone is doing something. The instruments agree on this. The scientists agree on this. In the careful language of their published observations and in the rather less careful language of their private conversations. What it means, whether it is episodic unrest that will subside as it has before, or whether it is something that the instrument record has never captured because nothing like it has happened while we were watching. Nobody can tell you with certainty. That uncertainty is not a reason to panic, but it is a reason to pay attention. It is a reason to understand what you are actually looking at when you look at those thermal pools and geysers and that impossibly beautiful landscape sitting on top of the most powerful geological force on the North American continent. It is a reason to take the data seriously even when the official language tries to sand its edges smooth. The supervolcano is doing something. The question of what comes next belongs to the geology. And the geology, as it always has, will answer in its own time, on its own terms, without asking for our opinion. All right, that is Yellowstone. And look, if this video did not make you want to look up USGS ground deformation maps at 11 o'clock at night, I honestly do not know what to tell you, because that is exactly what I did while writing this script, and I have not fully recovered. If you are new here, my name is Daniel, this is Natural Disasters, and this is what we do. We take the data seriously, we take the science seriously, and we try to talk about it honestly, even when honest means uncomfortable. If this video made you think, share it with someone who should probably also be thinking about it. Subscribe if you want to be here when the next number changes. And if you have been to Yellowstone recently and noticed anything unusual, I genuinely want to know. The comment section is open. Stay curious, stay informed, and maybe, just for the next few weeks, keep one eye on Wyoming. I will see you in the next one.